This video is going to be a real quick sneak peek at calculus-related rates problems. These problems are going to be solved using implicit differentiation. Oh, that's right, you love it. So hang in there, I'm going to show you 3 quick examples and then you're going to learn how to solve these things. Sand is being dumped off of a conveyor belt and forming a cone-shaped pile. Now the volume of the pile is increasing at a constant rate, but you'll notice that the height of the pile is not increasing at a constant rate. Right when the pile is quite low, you'll notice the height is changing very rapidly, but as the pile gets bigger and bigger and bigger, the rate of change of the height is slowing. So the volume is increasing at a constant rate, but the height is not increasing at a constant rate. The two rates are related to each other, but they're not the same. This type of problem is called a related rates problem, and we're going to learn how to solve them in calculus. It's the next thing we're going to do. Oh, I'm very excited about it. I hope you are too. So let's look at a couple more examples real quick. Here's another classic related rate problem. I have a 10-foot ladder leaning against a wall. Here's my ladder, and the ladder starts to slide. Now we could say that the top of the ladder is sliding at a constant rate, maybe 1 foot per second. And I want to know how fast the bottom of the ladder is moving, perhaps when it hits Bart Simpson there. Now, this is interesting. You'll notice that the top of the ladder is moving at a constant rate, but the bottom of the ladder is not moving at a constant rate. And you can see what's going on here. At the top, if I move the ladder a little teeny bit, look how far it moves at the bottom. But as the ladder gets close to the bottom, as I move the top of the ladder, now the bottom barely moves at all. So again, the rate of change of the top of the ladder is related to the rate of change of the bottom of the ladder, but the rates are not the same, and we are going to use related rates, yes, calculus, to find out how fast the bottom of the ladder is changing at any moment in time. Let's look at one more example. So here I have water dripping into a puddle. It's forming a circular puddle, and I could say that the area of the puddle is increasing at a constant rate. And I want to know how fast the radius of the puddle is changing at some moment in time. So again, these rates are related, right? The rate of change of the area is certainly related to the rate of change of the radius, but they're not the same. And actually, you can see that when the puddle is real small, the radius is changing very rapidly. And as the puddle gets bigger, the radius is changing at a slower rate. Again, we are going to use calculus. We are going to use related rates to figure out these problems. It's going to be so much fun. Hang in there, and thanks so much for watching. Okay, bye-bye.